Okay, we're going to get started. I want to welcome you all to the first ever sort of showing of SQL Server 2008. And the code name was Katmai. I hope that this one is the first and last ever first ever, because for SQL 2005 we had several Tech Ed first evers, one for each year before we shipped it near the end there. But we'll get into why this will be the first and last ever here in a few minutes. So we're going to run through and actually talk about some of the motivation for the release. We're going to talk about some of the context. I'll talk about some things we've done inside the development team in terms of how we actually have produced SQL Server, what will become SQL Server 2008. And then we'll do some demos. We'll show it in action, sort of give you a peek at what you can see later on in the week with SQL Server 2008. And there are a bunch of breakout sessions, so you can get down into the details, and we'll have some references at the end towards all of these, and a series of chalk talks. So pretty much anything you want to learn about SQL Server, the existing product, and SQL Server 2008, you can learn about this week at Tech Ed. So, and last but not least, if you have not yet received your June CTP of SQL Server 2008, I have up front here sort of what's left, because we've given out most of them, sort of a high demand this morning. So if you haven't gotten yours, we'll have you come up after the talk and pick it up. So we have a DVD here with the first public CTP of SQL Server 2008. And as I said, we'll distribute those at the end of the talk. Actually, hold on. I'm going to go back here. I'm going to tell you right now a little bit about how we've changed the development process of SQL Server. I just want to take a minute and do this, because this will set the context for the CTP and what you can expect to see rolling out with the CTPs. We learned a lot when we developed SQL Server 2005. The team had grown very, very large. One of the challenges we had was we started a ton of work in SQL Server 2005 across a very, very large team. And we found ourselves in this position sort of in the middle of development where we had, hundreds of things going, hundreds of improvements in SQL Server 2005, none of them really done. And so we spent the last 18 to 24 months getting all 500 of the things that we had in there, whatever the number was, from 90, 95% done to most of them 100% done, and a couple that we had to actually bail on near the end. So as a result of that, one of the things that we did after SQL Server 2005 is revamped the way that we actually think about a release, how we plan a release, and actually how we execute on a release. So SQL Server 2008 is the first one in which we've done that. So we're in transition, if you will. We're kind of learning. We're changing the process as we develop the product. What this means for you, we are actually now pipelining what we call improvements or features. We think about things in terms of themes, and underneath themes we have a number of scenarios. And we want to do scenarios end to end, and we want those scenarios to be complete. One of the challenges we had before with SQL Server 2005 is we had teams that would implement features, but we had no scenario coordination. So for example, we may have changed a bunch of things within the engine, and then the management tools team didn't find out until the end and actually couldn't respond. So we had things that really weren't complete in end-to-end when they got into your hands. So to address that, as I said, we start out with themes in terms of things that we execute on the release. Each of those themes has a number of scenarios, and we think about those in terms of complete scenarios that add value to you. And each of those scenarios has underneath it what we call an improvement. So you can think of an improvement roughly as a feature. The idea is we don't check anything into our main source line until we believe it is complete and pretty much ready to ship. What this means in terms of what you will see coming out with the CTPs, instead of having the first few CTPs contain a bunch of stuff but none of it really working or none of it really done, the way this process will present itself to you is you'll see a series of things that are done in the first CTP, but they should be pretty much done end to end. You'll see more stuff come on in the next CTP, again, done end to end. So the things that you do see in this first CTP are things you should be able to test and push hard, and if they don't work, let us know, because we've done a lot of work and we believe that they're pretty much end-to-end ready for your use and testing before we ship them out in a CTP. So that's how things will look differently. You won't see a bunch of things that are half done up front. You'll see things come in. And by and large, we hope they're done end-to-end. So some things we actually have to stage in several releases just because we need so much customer feedback, but we'll make you aware of those as well. Okay, so the next few slides, the context for this is basically how I'm going around and talking about the changes in the database space to CIOs and such and customers. And this is a motivation for this transition from, we think about things as just a database system to a data platform and what motivates that. So if I think about when I came to Microsoft almost 13 years ago, SQL Server was really a relational database management system with some client libraries and some bulk data utilities like backup, BCP. Things have changed dramatically in 13 years. And I want to share some of the drivers, and a lot of these are familiar to you. And then we'll talk through how the transition is playing out both in the market and with SQL Server, the product. So one thought experiment that I do is to say that, look, the cost of storing and acquiring data, as a thought experiment, think about that going to zero. Because if you do the numbers, it's just stunning. And this has had tremendous effect on how people manage data and these inversions in some processes. I'll get to that in a second. It used to be the case that people would put systems together, they would design a schema, they would decide how to load data into that schema based upon what questions they wanted to answer. They knew all of this stuff up front. Now what we see, people just storing data, whatever's coming off, whether it's coming from business activity monitoring, whether it's coming from RFID sensors, whether it's coming from other activities, most things today are now born digitally. If you go back 50 years ago, we paid armies of people to key punch stuff in a digital form such we could run it through data processing. Now, having it all born digitally gives us the opportunity to get more value out of it. And it's so darn cheap to store that people are now storing it, not thinking through up front in many cases what questions they're going to answer. The problem we had with people 2 and 3 years ago is they would throw things out. They would distill data to put it into the data warehouse, and then 6 months later realize, gosh, I wish I could ask those questions, but in the process of loading the data, I actually throw out information and facts that I could now make use of. So with this drive down in storage, there's a huge change there. Form factors. The data is moving up and out. There's a lot of people talking about consolidation, other sorts of things. But in my mind, data is both moving up and being consolidated, but it's also moving out. A lot of us are carrying around data on smartphones, on our devices, moving up to the cloud. So we see data moving across a number of form factors, and the implications there are, how do we care for it? How do we protect it? How do we synchronize it across all of those tiers? And we'll get into that. All different types of data types. So if you go back 20 years ago and you walked up to someone, you just landed from Mars, and say, hey, in 20 years you're going to be carrying around a device in your pocket that's going to have tens of gigabytes of storage, and you know what? All of your music, like thousands and thousands of tracks, is going to be managed in a database and stored digitally on this thing you'll carry around with you. People would have looked at you like you were nuts. And now we do actually, in fact, store these things. Other data types, digital images, whether they're from photography or whether they're from medical images, IM streams, people looking to index them, to maintain them, to protect them, all now being part of what we need to track in the traditional database world. And then finally, this whole notion of IT and regulatory compliance. I was speaking with some folks at a large financial institution in November, and they were going to offer IM support for their clients. Now, they could store the data. They had plenty of space to store it. They could actually figure out how they wanted to index it and track it. The thing that they couldn't do was protect it, because now with the newest laws, anything that's stored electronically is actually discoverable in some form. And their ability to protect it and then produce it in an efficient way was what was preventing them from offering that service to their customers at that point. And so there's a big driver there as well. So another slide that I use for talking about this is just where have the efficiencies come from over the last 50 years from information technology. And I'll run through this quickly. 50 years ago, we called this data processing. Actually, people typed things in, key punch things to get it to the mainframe, and we did order processing in 30 minutes instead of 3 days. Then during the 70s, we started doing transaction processing. We got enough space online to do online transaction processing. From there, we got reporting. And then we got into the world of communications in the 90s, by which latencies between processes, so think about doing a purchase order flow either through mail or fax, which may have taken days, even weeks, hours. Now that latency, just getting the information back and forth, dropping now to sub-second in total. B2B services, XML as a means for representing data going across these services, and the internet for the means of gluing it all together. So now where does that leave us in terms of the next frontier for efficiencies? I think a lot of it revolves around, one phrase I could say is where information meets people. Okay? So we've got the data stored. How do we turn it into insight, and how do we get it to the right people so they can act on it? So things like knowledge retention and retrieval. If we can just store everything, the question is how do we get back at it? And the stunning thing is, you go back to the first PC you had if it had 10 megabytes on it. Now, we've got I've got a 100 gigabyte hard drive, and I pretty much just carry everything on it and copy it from machine to machine on my notebook. Challenge then, how do I get at it? How do I find things that I've stored on there? Services overall data, we'll talk about this. And then reducing latency in those processes where information meets people. How do you turn things around, make decisions quickly, record the decisions, and move on? So the umbrella for this could all be where information meets people. I believe that is the next frontier, if you will, for information technology efficiency. We'll talk about that. So another lens on this, we talk about the pre-monolith data processing. Monolith in terms of getting things together in single databases, where I pulled everything together in one database, started one transaction, made changes, committed it, and the world looked different. Then if you think about sort of the late 80s and through the 90s, it was where the data monolith actually ruled. And if you think of very, very large-scale enterprise applications, these were forces for pulling data together in one place. In fact, they were forces for people to redesign and re-engineer processes in their business. So for some very large-scale enterprise applications, many companies, when they first deployed them, had to re-engineer their business processes to fit in to whatever was modeled within these large enterprise applications. But it was worth it for them based upon the value that they then got out. And what was interesting is we had these very large monoliths, and we started to glue them together. So if you think about EAI, a means of actually, instead of thinking it in the context of master data management, he thought about it in the context of actually getting the data from the HR system in through the ERP system and work scheduling system. So EAI was sort of this transitional thing. So another way of looking at this, through about almost the turn of the century, forces generally tended to pull data together in one place to process it, from the mainframe out through large enterprise applications. Then, around 2000, the natural forces in data started to pull it apart, whether it was due to scale, whether it was due to business-to-business services, service-oriented architectures, getting information out to devices. It really did tend to pull things apart. And so now we've got this coupled with all of this data coming together. The other way of looking at it, and I think this is a really important thing, is you go back, say, 40 or 50 years ago, it was machine-centric. We had a couple $1 million mainframe. We brought the information to it and did our work. Then it became application-centric. I think right now we're really at the cusp of turning things into being data-centric. You focus on the data, and then the applications are around it. So in some sense, it's what is at the center of the universe of all of this. And we are now making the transition into a truly data-centric environment. And that's what's driving a lot of us. So that's sort of some of the setup for this. And if we go through and think about SQL Server 2008, I'll talk about a few things here. We'll click through. And on the left, this enterprise data platform, the beyond relational, dynamic development, and pervasive insight. Those are the themes. So when we started going through and planning the release, these became the themes in which we talk about sort of the value in the release. Now on the right-hand side is sort of an interesting picture. At the bottom, we can see the various tiers or locations of data, whether it's on a device, mobile and desktop, or in a server, or having data up in a cloud. We want to be able to work across all of those tiers. And if we think of the services we provide over that data around the outside there, query analysis, reporting, integration, sync, search, and otherwise, if you go back to when I first started working on SQL Server in 1994, the services were pretty light. We had query, and we had some bulk utilities, load, unload, backup, and such like that. Our services, analysis, reporting, integration, synchronization, replication, search, have gotten much richer. Now, here's an interesting thing, and this sort of foreshadows a lot of the investment we made for SQL Server 2008. When we plumbed each one of those services, we actually built a stovepipe around the data model. So for synchronization, we said, how are we going to describe what we're synchronizing? We built a model for doing that. For OLAP, we said, how are we going to describe information cubes and how are we going to describe the entities that are in the cubes? We built a model for that. Within reporting and Report Builder, we built another model for describing those. And what we realized in doing this is to say, okay, we can converge these things around a single model. So when you start thinking about how to manage this data in a platform sense and build services on top of it, you need a common base in which to build those services such you don't have to re-describe things over and over again. So the interesting thing, the way I think this plays out, I've heard it many different ways, but a lot of people have said, okay, it's about the representation. When we introduced native XML support in SQL Server 2005, many customers said, oh, now my life is great, because I'm just going to think about things as XML end to end. And they'd start describing to me how they were going to use XML to build their order processing system. And I'd have to, Michael Reese is up here, he's one of our XML gurus. I'd have to kind of slow him down and such. It was about representation, because people thought if they had it in one form or another, their lives would get easier. The way I think about it, conceptually, a purchase order within some domain, and that domain could be your company, a set of applications, is realistically the same thing. It has the same set of attributes. Now, when that purchase order is being printed in a document, it's still a purchase order. It's in one representation. When it's in an XML fragment going back and forth between web services, it's still a purchase order with the same attributes, but its representation is different there. When it's stored in a relational database, it's still a purchase order, different representation there. If I'm programming against it in a CLR, still a purchase order there. When it's on a form, again, it's still a purchase order. So we said, how can we make use of this and allow you to describe the purchase order once and then make use of that same conceptual entity across all sorts of those representations without having to recode it for all of those environments? And if you look in the middle here, where it says entity data model, that's sort of the means for pulling this all together. So SQL Server 2008 is just the first step on this bigger vision. And if you look at it, just in what we're shipping in SQL Server 2008, you can see part of it. But again, this is part of a very, very big vision in terms of how this plays out as a platform going forward. So we used to have this slide, and this is sort of the eye chart slide. We had some of you might remember, we had a slide in the SQL Server 2005 deck, which people would say, what's in the release? And it was this nut to 10-point font on a PowerPoint sort of thing. So this is, people ask me, okay, is SQL Server 2008, it's a tiny release, is it a bigger release? It's a very interesting release. There's a lot in it. And so one way of saying this instead of being 10-point font is a 14-point font. So this is, you can say that SQL Server 2008 is a 14-point font release. And there it is right there. We'll cover a number of these things today, and you'll get into more of the rest of them over the course of the week. So now let's sort of drill into some of these things. I've got a set of slides on each of these, and we'll get some demos up in here around some of these as well. First theme is Enterprise Data Platform. And this is something that is in our genes. We're always talking about what it means to make the product more mission critical. How do we put more in that way? Things that we've got going on in this release. Secure, trusted platform for your data. That would be the scenario. Improvements in there. Transparent data encryption. The ability to just mark the application database as encrypted and not have to worry about what you do beyond that. So with SQL Server 2005, we introduced encryption primitives. They were great building blocks, but now we built it out as an end-to-end improvement. External key management. We built key management into SQL Server 2005, but more and more people in larger enterprises are using third-party key management solutions. And this improvement allows us to integrate with some of those solutions for those companies that have adopted a third-party or enterprise key management strategy. Data auditing. We always had the ability to sort of audit certain sets of changes. Now we have Audit DDL, in which you can actually audit someone who's changed a particular attribute beyond a specific value, who's done what, when to the data. The ability to do hot add CPU. So this is an enterprise class feature. If the hardware supports the ability to add a CPU to a running system, SQL Server 2005, we had introduced hot add memory. Now we've got hot add CPU. And then transparent failover. This is an enhancement to the database mirroring work that we had done for SQL Server 2005. Productive policy-based management of your infrastructure. Some of you who went to the keynote saw a glimpse of this morning. We're going to do a demo of this in a few minutes. And one way I think about this is as data moves up and out, so there are forces pulling together things for consolidation or other forces tending to pull things apart. And one of the challenges when you scale things out and distribute data, how do you get your management costs to stay relatively constant while you increase the number of servers? And one framing of this, if you have 1,000 SQL servers deployed, if you step back and thought about it, you actually might have a handful of classes that they would all fall into. There's some that would be SQL servers that live under someone's desk, their development machine, you don't really care too much about that. Others might be smallish work group applications. You want to make sure I've got a backup strategy on that. Maybe I just do a simple backup once a night. Others are mission critical and fall under a different set of service agreements and such. So if you were actually able to define those handful of policies, and then instead of having to turn the knobs on all 1,000 servers to get them to fit into one or another, if you could define the policies and then when you introduce a server, fit it into one of those policies and then make sure that it stays within those policies, and if it falls out of compliance with what was specified in the policy, that you could find out about it and then actually make the changes in some cases automatically, that would be a wonderful thing, and that's what we're talking about here. So server group management aligned with that, streamlined installation, and then integration with enterprise system management. So one more slide. Dan's going to come up here and show us that in just a second. Optimized and predictable performance. So one of the things that we found in very, very high-scale systems, people want to be able to collect and trend performance data. And so we've got a performance data collector, which we can build a performance data warehouse out of, and then do trending capacity analysis, capacity planning out of that. The ability to analyze that performance data and make recommendations and trends. Data compression, the ability to do aggressive compression on the data, saving both in storage costs and just bringing more and more data together. Now, the interesting thing from a hardware perspective is that the CPU speed has gotten so much faster relative to disks that the ability to compress things, bring them through much of the system in compressed form, and then decompress at the latest possible point. We used to think of compression as being CPU intensive, but the CPU power has gotten so fast, or we've gotten so large, that we can actually afford to do the compression and decompression, and it makes more sense for us to actually get more data per gulp, if you will, and then decompress later on. So data compression paying off in multiple ways. Query optimization modes. So this means, is this more like a TP, a transaction processing system, or data warehousing system, and how do we want the optimizer to respond if we can tell it what our intention is. Resource governor. In these consolidated environments, more and more people want to be able to apportion resources to various classes of user, classes of query and such. And so the resource governor is an improvement for that. And then backup compression. A lot of people have been asking for several years for us to introduce backup compression natively in the product, and that will appear with SQL Server 2008 as well. So now with that, I'm going to turn over to Dan Jones, who's up here. Dan is the improvement lead for all this, the magic, and we're going to switch over to show some of that.
All right.
Okay.
Can everybody hear me okay? Great. All right, I got to do There we go. Terrific. Okay, so as Dave mentioned, I'm going to give you a little taste of declarative management. This is our new policy-based administration feature in SQL Server 2008. This is in the CTP, so the June CTP that we're handing out DVDs for, and that's downloadable. What I'm showing you here is available in that CTP. The first thing I want to do is just create a table. And I don't have, there we go. Okay, great. Nobody ever got applause for creating a table, right?
Yeah.
All right, thank you.
Yeah.
Okay, now that's all great and interesting. You can create a table. However, I have a policy on this database that prevents tables from being created in a DBO schema. This allows DBAs to control the system so that people don't inadvertently do things on the system that they don't want them to do. So let's try to create a table in the DBO schema. Aha. My table create failed. And it failed because we violated a policy. What happened there was we intercepted the create table transaction. We went out to see, are there any available policies, any active policies on the database? Lo and behold, we found one. We evaluated the table create against that policy because it violated the policy, and the policy was set up to prevent those types of changes because we don't want the database to come out of compliance. We failed the transaction and rolled it back. Now let's take a look at a policy in a different type of mode. So there are certain classes of policies that you don't want to prevent the transaction from occurring in the system, but you want to record the results of the transaction or the results of the policy. So we're going to create a little database here, and I happen to know that I have a policy governing create database that says auto shrink must be false. Now I just set auto shrink to true because I want to violate this policy. So now the database is being created. On a separate thread of the create database, we're evaluating the policy. Perfect. So our database got created. So there's my test DB. Now that looks a little bit different. I have this icon out here that tells me that the database is now violating some policy. It's out of compliance with policy. Let's go find out what policy it's violating. So we'll jump into the database and we'll view our policies. There are 2 active policies on this database. One, we're in compliance. Our compatibility level is Katmai or SQL Server 2008. Our database settings, though, shows us that we're out of compliance. So let's run this policy and see exactly where we're out of compliance. We can drill into the policy. The policy defines the setting for 4 different properties: auto close, auto shrink, update stats, and create stats. Auto shrink, the expected value is false. The actual value is true. When we created the database, we set it to true, so we violated that policy. Now, what do you do from here? You want to bring the database back into compliance. Well, there's a few ways you could do that. You could author up an alter database script to set auto shrink to false. You could go back to Object Explorer, right-click on a database, bring up the database properties, find the auto shrink property, set that to false, and save those changes. Or we could let the policy do the heavy lifting for us. We can use the policy to reconfigure the database and bring it back into compliance. So here I'll select Configure. It reran the policy, configuring the database to comply with it, and now our auto shrink is set to false.
So you could have done that automatically and say that the policy will automatically address it right there without having to go back in again, right?
Possibly.
Is that next? Is that next?
Not in this CTP.
Okay.
All right, let's jump back out. We'll refresh Object Explorer, and now our violation on TestDB is gone. So we're back into compliance. If you want to learn more about declarative management, I have a session Wednesday morning, 10:15, where I'll jump through declarative management in a little more detail, and I'll also review many of the other manageability features that we're bringing online with Katmai.
Super. Thanks, Dan. Good job. So that looks like it'll be a big help for a lot of DBAs in terms of setting things up and keeping them the way they want them. Okay, so next thing I'm going to focus on is dynamic development. And as I go around and talk to people who are building applications and trying to get things done, one of the questions I ask now is how important is time to solution? And I ask this of CIOs, I ask this of SIs, I ask this of people in development on development teams and such. And it's hugely important. The ability in today's world to recognize a business problem and turn around and provide an answer, whether that answer is in the form of a report, whether that answer is in the form of an application, whether that answer is in the form of going on and doing some mining and analytics against the data to figure out some correlation. That response, the time to solution or answer, is huge. Okay? So that's something that we focused on in this release. Another thing is this notion of being able to synchronize data and provide offline access in a very simple way. So for those people who had moved to Outlook 2003 on Exchange with cached mode, it was a beautiful thing. I didn't have to synchronize before I left anymore. When I had connectivity to the network, things would synchronize. If I lost connection, I wouldn't really even know it. my mail would tend to accumulate. As long as there was something there in my inbox that I could work on, life was good. I'd stop at the airport, fire up the wireless, things would go back and forth, and it was actually a very nice environment. It took a lot of work to be able to pull that off between the Outlook and the Exchange teams. Our view is that we would like to enable application developers to be able to do that style of application without tens or hundreds of person-years of effort. And that's one of the things that we're working on in concert with the Visual Studio team in this particular release. So we'll talk about those real briefly. I'm going to go back and motivate sort of this notion of entities real quickly again. So in the storage platform, we'll get into some of the details in this in a minute. We've had relational data in the platform for 15 years. We've had XML data in for a number of years natively in the engine since SQL 2005. Being able to do a great job in terms of streams of data, we now have something we'll talk about here in a few slides with SQL Server 2008. And then spatial data. We'll talk about, we have something in there for SQL Server 2008 as well. So more and more types of data being known to the system. So frankly, I think that space and time, not in the sense of date time, but time in the sense of being able to go back and forth within the database, will be integral parts of the data platform as we move forward. So, and then we have these services, sort of these things that we've provided over all of these forms of data. And I talked before about really what you want to think about are the business entities, and customers, and orders. So when you write a report, you want to write a report on customers. When you do a search, so here's a good example. So if you were to do full text search of a database, and you had an addresses table that was linked in with a key relationship with a prospects table, with a customers table, with a suppliers table, if you did a search on a particular zip code, you wouldn't really want to get back rows naked from the addresses table. You wanted to see them in context. You wanted to see a zip code and those suppliers that were in that zip code. Those customers were in the zip code and such. And so the ability to describe the bounds of these things as entities really helps in that context as well. And when you go build an information cube and you want to see customers, my orders by my top customers by region over time, again, you want to do it at that level, not have to specify the joins across 3 to 4 tables to go produce a customer. So with that, the following things actually become much easier if we have this description. We can develop the enablement of these applications and other solutions very, very quickly. So imagine at some point, as we evolve this entity data model, one of the aspects of the model might be UI composition hints, whereby for every attribute in the model, we could say, here's the label that I want to go with that attribute. And in general, here's how I want the layout of this to go, such that I could take that, drag it out onto a design surface for a form, and whether it was a WinForm form or web form, InfoPath or such, I would get a default rendering without having to go, type it all up and put it all out there. And imagine on that end, on the information worker side, that we've enabled search as I just described. And then for IT professionals, imagine the following thing. Imagine one of the aspects of an entity model was the notion of tagging of information class. So let's say that I build a model of a customer, and one of the attributes of the customer is their credit card number. And I could associate a tag with that credit card number that says that this is financially sensitive. And then what I could do is define a policy against financially sensitive information. Now we could do the following thing. As that model was instantiated across a number of databases, I could run queries of the following form. Show me all databases that contain financially sensitive information. That's an interesting query. Now I want to define a policy that says that any database that has an entity in it that is tagged as with financially sensitive information, the only way that a client can connect to that is through a secure channel. Or any backup that I take of that database needs to be in an encrypted form. So these would be very, very interesting for the information lifecycle as well. So again, I talked about this with SQL Server 2008. It's just the first step and try to give you a glimpse of the other ways that we can use this model going forward. Okay, so when we talk about the entities, we talk the entity data model. It's out there right now, has been in CTP form. Language integrated query over entities, very interesting. Visual entity designer, which we will show at some point, and entity aware adapters. such that we can bring things from various forms. I think it's interesting to bring entities together, cache them many times over different sources. So people will pull data from various places, pull it together, and integrate it as a particular entity for the business. So, talk about the other thing that I mentioned, connecting your data from any device. SQL Server change tracking in the synchronized programming model. We call it occasionally connected systems. That's the name for the scenario. And the idea is that we've got the end-to-end experience that is plugged in with synchronization. So rather than saying, hey, we've got a number of replication or synchronization tools, go figure out how to use them together, we've brought them together to solve this particular scenario around being able to build these occasionally connected applications. And I'm sure there's a session here this week where you can go in and see some of the details on that. Steve Lasker, there is Francois nodding his head, Steve Lasker is the name of the guy. If you can track him down, he'll be more than willing to show you what we've got going on in that space. So now we're going to talk about beyond relational. This is very exciting for me as a guy who has started, we just put in rows and columns and tables into the database and now doing so much more. So file stream. One of the age-old questions, and I call some of these mixed mode applications. People have been building applications that have sort of married structured and unstructured data for several decades now. And the age-old question was, well, I've got this application that has, blobs or streams of data. Do I store in the database as blobs, or do I store the streams in the file system as files and store the name of the file in the database? And it's one of these, you'll find people on all ends of the spectrum in lunacy at the polls, right? And so there are probably 5 ways to go try to do this. Within Microsoft, we've tried all 5 of them and almost shipped, shipped 2 and almost shipped a couple others. FileStream is a great integration. It marries the best of the file system with the best of the database. So we've been working with the file system team for a number of years. So if you've been following with Vista and Longhorn, the transactional file system. So this is an integration of the transactional file system with SQL Server. So what you can do with this is actually annotate one of your blobs in the database and say that it is a file stream. And then the blocks are managed on disk by the transactional file system, but it's completely integrated with the database experience. So when I back up the database, it all gets backed up. I can do point-in-time restore, I can do roll forward and such. Now the interesting thing is I can go program against those things just as if they were blobs, but I can also go and get a Win32 handle or a stream to it and program against it in that way as well. And when I do that, we can just stream things right out through the memory manager within the operating system, and the performance is great. Okay, so there's a very tight integration, great experience there. Integrated full-text search. In SQL Server 2005, we integrated the admin experience around the catalog, being able to back it up and such. With IFTS, or integrated full-text search, we actually bring the indexes into the database. This affords us the ability to have the query processor reason over both the unstructured query, the full-text query, and other aspects of a query. So if you have a query that goes across structured data and unstructured data, we can now have the optimizer be aware of that. Sparse columns is the ability to have property sets, if you will. That's the way some people think about it. In having rows that might have hundreds or thousands of columns with a small subset of them populated and have it be very efficient in terms of storage. The other thing I didn't mention, didn't put on the slide here, is along with sparse columns, something we call filtered indexes. So what you would like to be able to do is if I have sparse columns and I'm going to build indexes over them, let's say one of my columns that is sparse holds some sort of status, and 10% of the rows in there have the status, but I want to build an index on that. I don't want to index all of the null values. I want to just index those that contain data. And it's not just a not null index. It actually has the ability to do some expressions within there as well and define a predicate on which the index is defined. So it's pretty interesting stuff there. Large user-defined types. So in SQL Server 2005, UDTs were constrained within a page size. And so now they're larger. You can define UDTs that are larger than a single page. And then, and last but not least, date and time data type. And for those of you Rocky and Bullwinkle fans, this is sort of like this time for sure, right? We had tried doing this. People have been asking for this for 10 years. So finally, we've got it done and done the way people want it. So people are excited about that. So, okay. And now, location. So being able to store and manage geometries. So many more applications are now geometry. We've got location awareness, GPS, and so it's very, very cool to be able to bring this into the database and build these mixed mode applications with respect to space and other structured data. So Michael Reese is coming up to join me. Now he's kind of like doing this without a net because I asked him to do this demo, and he's got it running on a machine back in Redmond. So he's VPN'd in from here through terminal server to a machine back there. And if it hasn't logged him out, he'll be able to demo it for us.
It hasn't logged me out, but I will be back in a second.
Okay, and I think we need to switch you over. I think you're
Yes.
on F. Is that what you were?
Exactly.
Let me see if I can hit that. Is that you?
Yep,
That's you.
that's me.
And you're going to share so we can get it on live meeting.
Yep. Can everyone see it? Okay, thanks. So what you see here is a couple of small demos of our new spatial support, both spatial type and spatial indexing with SQL Server 2008. Both of these features, the new types, we have two types actually. We have a spatial geometry type that is for planar geometries like warehouse layouts, and then we have another two-dimensional spatial type called geography, which is for GPS coordinates. And the spatial indexing will be available in subsequent community tech previews. So this will not be in your June CDP. And that's also why I run that remotely. And what you see here is a virtual Earth or locallife.com image of our area here. You see here the Convention Center International Drive. And what I want to show you now is basically a point click intersection of such that when I click here, it will go back to the database, retrieve the information about the zip code area that is stored inside the database, and then will mash it back into as a layer on top of the map that you see here, and it will show basically what the zip code boundary is of the area where we have our convention center. So I click once here, and you will see that it will take a while until it actually shows something, and now we get the data back out of the database. Now, if I do the same, let me quickly refresh it. If I use the index that I have specified inside my database, and I do the same, click here, you will see that this information comes back almost instantaneously.
So it's using the spatial type and spatial index.
Yeah.
That we've got.
Just to show you what actually happened, I have a SQL profiler running here. And you see here the first query that I have been running is basically just a simple